Good evening one and all, this is Y.Renuka from 3rd Ece-C bearing roll number 19BQ1A04H5. Now I am going to discuss about lowering antenna heights and methods to reduce co-channel interference from cellular mobile communications. Lowering antenna heights. Lowering antenna height may or may not efficiently help to reduce received power at different areas. Let us discuss about mainly three different areas: hilly terrains, valley terrains and forest areas. Hill terrains. The effective antenna height rather than at the antenna height varies according to the location of the mobile unit. When the cell site antenna is on the top of the hill, then the effective height of the antenna is He1 is equals to H1 plus H. If we reduce cell site antenna height to half of, then the new effective height will be Het is equals to 0.5 H1 plus H. The change in range received at the mobile unit is G is equals to 20 log He2 by He1. By simplification we get G is equals to 20 log of 1 minus 0.5 H1 by H1 plus H. If H1 is very less than H, then G will be 0 dB, that is gain at the receiving point will be 0 decibels. This proves that the lowering antenna height on the hill does not reduce received power either at the cell site or mobile unit. Let us consider this. The antenna is at the top of the hill and the height of the antenna is H1 and the height of the hill is capital H. The effective height H is equals to H1 plus H, which we discussed before. Now coming to the valley terrain, the effective antenna height as seen from the mobile unit is He1, which is lower than the actual antenna height. Therefore, He1 is equals to 2 by 2/3 of H1. If we reduce the cell site antenna to 1/2 of the H1, then a new effective antenna height He2 is He1 plus 1 by 2 H1 into 1 minus 2/3 of H1, nothing but 1/6 of H1. Then the gain will become 20 log of 1 by 4, that is in terms of negative, that is minus 12 decibels. This proves that the signal received at either mobile unit or cell site will be weaker in valley terrain. If we place mobile antenna height adjacent to the cell site antenna height, then the change is gain reduction by lowering antenna height is represented as He1 is equals to H1, He2 is equals to half H2, then gain will be minus 6 decibels. Coming to forest areas. In forest areas, the excessive attenuation will occur due to the trees and signal reception at mobile unit is weaker. To get good signal strength at mobile unit, we have to place this antenna on the top of the trees, which is very difficult. Now our next topic is methods to reduce co-channel interference in cellular system. There are three methods to reduce co-channel interference in cellular systems. So they are: first one, separation between co-channel cells should be increased. Second one, lowering antenna heights. Third one, using directional antennas to reduce interference. Method 1 is not advisable because as number of frequency reuse cells increases, the number of cells per cell decreases, which is directly proportional to decreasing spectrum efficiency. Method 2 is recommended because such an arrangement weakens the signal level at different areas like in valley terrain and forest areas. Method 3 is a good approach when frequency reuse concept is introduced. The use of directional antennas have two main purposes. First one, further reduction of co-channel interference if the interference can't be eliminated by fixed separation of co-channel cells. Second one, increase the channel capacity in heavy traffic areas. Thank you.